Okay, so hello everyone. So our today's topic is simplifying radical expression. Okay, so we having some really important property in this topic. Okay, we having some really important property. So let's go straight to the first property of the radical. Okay, for any non-negative value. Okay, any non-negative value. Real number a and b, we having this statement. Okay, but the thing important to know is that the number have to be non-negative. Okay, have to be non-negative real number. Okay, so let me actually zoom in a little bit. Okay, let me actually zoom in a little bit. Okay, so okay, yeah, okay. So we're gonna actually talking about the example first to actually show you, actually demonstrate how this property is actually going to work. Okay, so this property is really important. Okay, so as everyone know, so we having a square root of 12, right? So okay, we have a square root of 12. So 12 is actually equal to 3 multiplied by 4, right? So we can actually using the statement over here. So this is just gonna be 3 and then you multiply by 4, right? So as the statement say it, right? The statement. Let me actually read the statement over here. The statement over here is say the square root of AB is actually equal to the square root of A multiplied by square root of B. Okay, so over here we are basically applying the property, right? Okay, so after that, let me actually solve this. Okay, so we can actually simplify a little bit. Okay, so we having a 3 over here. So square 3 is you know, you cannot make 3 into something power of the 2, right? So the integer 3 we cannot make this number into something to the power 2, right? But over here 4 is actually 2 to the power 2, right? 4 is actually into the power 2 to the power of 2. So 2 and 2 get cancelled. Our final solution will be 2 to the square root of 3. Okay, so let me actually write it down. 2 to the square root of 3. Okay, so that's 2 to the square root of the power square root of 3. So that's how you read it. Okay. So over here, another example I want to show you guys is why the number for A and B, why the number over here, why the condition, why we need to have in the condition. Let me actually organize again. So another example I want to show you guys is the why the number over here have to be non-negative real number. Okay, let me actually write it down over here. Okay, why the number have to be non-negative. Okay, why the number have to be non-negative? Cause you know, we having something like okay, so the example over here is I want to show something like suppose we having some negative number, negative 9. Okay, so as you can see, you know, a square root equal to negative 9. Okay, so as everyone know that, you know, right? So we having we having a square root, and then we having a number which is negative 9. So in order to actually solving this solving this square root, right, we need to have some statement like this. We need to have some statement like this, right? X squared is equal to negative 9, right? So as everyone know, x squared, the x squared have to be bigger and equal to 0, right? But the number over here is negative 9, so it's undefined, right? So it's actually undefined. So that's why we need to have non-negative number. Okay, so that's basically why over here we need to have non-negative number, cause over here we are specifically talking about the square root. Okay, so cause over here we are specifically being talking about the square root, right? So that's therefore we need to have non-negative real number. Okay, because if we have a negative number, then everything will be undefined, right? Okay, so that won't make sense. Okay, so that's why basically that's one of the condition. Okay, so let's talking about the second property. Okay, the second property, the second property of the radical, the property is saying about that for any positive real number, for any positive, okay, and positive basically means non-negative. Okay, positive real number a and b, we having this statement. Okay, so let me actually read this statement first. So the square root of a over b is equal to the square root of a over the square root of b. Okay, so that's basically the statement. Okay, so let me actually using this example. Let me zoom in a little bit and then this example to show how you actually applying property. Okay, according to the property, we can write this into this, right? So we can write in the square root of 16 over 4 is equal to the square root of 16 over the square root of 4. Okay. So 16 is equal to 4 to the power 2. 4 is actually equal to 2 to the power 2. So it just basically become 4 and then 2. 2 get cancelled. So that only the final solution will be 2. So another easy way, let me actually solving this problem in another way. Okay. So as you can see, 4 get cancelled, 16 become 4, right? And all we have left is the square root of 4, right? So 4 is actually 2 to the power 2, so our final solution will be 2, right? So that's actually a little bit, that's actually more faster, right? Okay, so you know, this is the process which I apply the property of it. Okay, let me show everything. So this part of process is actually I show how the property work. Okay, but you can this thing over here is more faster. Okay, the second method which I use is you can solving this problem much more faster. Okay, so now you know we have already talking about all of the properties. So let's move into the question section. Okay, let's move into the question section. So we got, let me take a look. So how many questions will we have? We got totally 5 questions. Okay, we got totally 5 questions. So now is the time for you to actually skip some questions. Okay, so if you feel like some questions are easy for you, so some questions are easy for you, then so make sure. So now is the time for you to actually skip it. Okay, otherwise I was talking about all the questions in detail. Okay, so yeah, so if you don't know, I was talking all of them in detail. Okay. So let's look at the first type of problem. Okay, over here we want to simplify each radical expression. We want to simplify it. Okay, and we are assuming all variable are positive real number. Okay, so that basically means you can applying the property all the time because everything is positive. Okay, so basically you can apply the property. Okay, so let me actually zoom in a little bit and then let's do the first question. Okay, the first question what we have is we having a square root, and then we have 90. We having a number. We have 98 m to the power 4 inside, right? 98 m to the power 4 inside. So as I told you guys before, how you actually solving square root is you want to make something to the power 2, right? You want to make something to the power 2, right? By example, maybe something like you have something like something like something like 4 to the power 2. Okay, you want to make something to the power 2. Okay, so that's the key idea about how you actually solving the square root, something to the power 2. Okay, so now let's actually thinking. Okay, so over here, let me write it down. Okay, over here we have 98. 98 is actually equal to 2 multiply 49. Okay, multiply 49. Okay, so basically over here you write it down. 99 is 4 multiply 49. Yeah, sorry, 4 multiply 49. Is equal to 4 multiply 49 to the power of 4, right? So now what you're gonna do is that you know that 49 is actually equal to 7 to the power 2, right? 49 is actually equal to 7 to the power 2, and m is actually equal to m squared to the power 2, right? m to the power 4. M to the power 4 is actually equal to m to the power 2 to the power okay, so m to the power 4 is equal to this. Okay. Okay, so now we are actually going to apply some property over here. Okay, so as you can see, we having a single 2 over here, so you can just write it down. You can just moving this outside. Okay, and we having this part, right? So we having this part, so we can making this part as a square. All right. Okay, so you can see we having a square over here, and then we having a square over here, right? So you putting the power 2 outside of the bracket, right? And then you write it down 7m squared, right? Okay, so now as you can see, so we having a square root, and then inside we having a power 2. Those things get cancelled, right? And our final solution is 7m square root of 2, right? You can actually write this a little bit more properly. Okay, yeah, you can actually write it down in this kind of way. Okay, so now we have already solving this question. Okay, so as I said, the key idea about how you actually solving a square root is you want to make something to the power 2. Okay, all I have been doing over here is I try to make something to the power 2. So after that I can simplify it. Okay, so now let's move into question 2. So question 2, you look at it, and then you see we having a square root, and inside what we have is 200y to the power 6, right? Okay, so as everyone know, 200 is equal to 2 multiplied by 100, and 100 is actually 10 to the power 2, right? So as I said before, if you want to simplify the square root, you want to cancel the square root, you have to make something to the power of 2. Okay, so let me actually write it down. 200 is actually 2 multiplied by 100, and then y to the power 6 is actually equal to y to the power 3. The outside is 2. Okay, y to the power 3 and to the power 2, right? Okay, so let me take a look again. Yes, okay, so after that you have to doing you basically have to apply in the property. Sorry, okay. Sorry, yeah, sorry. So let's go back to it. Okay, so now after that you have to simplify a little bit. You have to so over here we have 2, and then you know that 100 is actually 10 to the power 2, and then you write it down the following. Okay, because we don't have to change it. So after that, yes, we have in a single 2 over here, so we can just pull it pulling out the single 2, right? The single square root of 2, the single square root of 2. So that's one of the and then we multiply. So as you can see, we have in a square, we have into the power 2 and then another power 2, right? So you can actually combine them together, right? So you can actually combine them together. Let me take a look. 10y to the power 3 to the power 2. Yes. So as you can see over here, this part I actually applying the property, right? So we having a square root. We having a square root over here, and then we having a power 2 over here. So those things get cancelled, right? And our final solution will be 10 square root of 2y to the power 3. Okay. Okay, so as I said before, all you have to do is trying to solving square root is you try to make something to the power 2. Okay, try to make something same as the nth root. Okay, say if you having a same as the nth root. Okay, so you try to making something to the power of n. That's the same logic. Okay, so now let's move into question 3. Okay, question 3, you see, is as I tell you guys before, one of the conditions is that the question tells us all variable is positive, right? So over here, the question is assuming all those variable is positive, so we are actually able to perform any property over here, right? Okay. So over here you can see we having x to the the square root of x to the power 3, y to the power 4, z to the power 2, right? So x to the power 3 can be written as x squared multiplied by x, right? Okay, and y to the power 4 can be written as y to the power 2 to the power 2, right? And then z squared is just simply z squared. Okay, so as you can see, we have x squared, y to the power 2 squared, and then z to the power 2, right? So now we can and we having a single x, right? So we can actually using one of the property over here. So you can actually pulling out x, and then since things in the other things, everything have the power of 2, so we can actually combine them together, right? So we have x y squared z to the power 2, right? So let me actually check again. Yes, so now we are able to cancel some terms, right? So as you can see, we having a square root, and then we have something to the power 2, so those things is gonna get cancelled, and then we have our final solution: x y to the power 2 z square root of x. Okay, so that's basically our final solution of it. So okay, I think I repeat how you actually solving a square root many times. Okay, all you have to do is making something to the power 2. Okay, so alright, yeah. So next, let's move into the next type of question. Okay, so I think this we only have 2 questions left. Okay, so let's read. So over here, the question over here is say that we have to using the property. We have to using the property, of the radical to actually simplify it. So we want to simplify each equation. Okay, and we are assuming that all variable is positive. Okay, positive real number. So you basically apply any property over here. Okay, and basically over here we want to using the property to actually simplify it. Okay, so let's move into question 4. Okay, let me actually zoom in a little bit. Okay, so over here you can see question 4, we having a square root, and the statement inside is actually 2x over 5, right? So as you can see over here is that we actually have no way to actually making a square root, right? We based on you looking the thing inside 2x over 5, we just cannot making something to a square to something to the power 2, right? So over here what you have to do is, because we want to simplify it, right? So how you actually simplify over here is you basically multiply by 1. Okay, you want to make sure it is equivalent. So you multiply 5 over 5, which is equal to 1, right? So after that you find that we having a 5 square as the denominator, and on the top part we having a 10x, right? So over here, after we multiply by 5 over here, we have now what we have is 10x over 5 square, right? So basically our final solution is basically this. Okay, 5 square, right? So that is a 5 square. So 5 square. So the 5 to the power 2, the power 2 is gone, and then what we have is 5, right? Okay, and on the numerator, it will be the square root of 10x, because we cannot make anything to the power 2, so we just left as it is. Okay, so let's move into question 5. Okay, question 5, since this one is actually the last one, pause the video and then try to do it by yourself. Okay, pause the video. Okay, so again, you look at the question, we having a square root inside is actually this 12 x to the power 3 over 5, right? As I say, this question is not really difficult. All you have to do is to simplify. You trying to simplify the denominator. Okay, so over here we want to simplify. Okay, so you basically have to multiply by 5 over 5. So simply you multiply by 1, 5 over 5. The reason you want to multiply by 5 because you actually want to get rid of the square root on the denominator. Okay, so let me actually write this a little bit more clear. Okay, so over here what we have is 5 to the power 2, right? And on the numerator what we have is 16x to the power 3, right? Okay, so after that I'm gonna show you guys one of the property. Okay, the one of the property is this, right? So it's actually equal to the square root of 60 x to the power 3 over the square root of 5 square, 5 to the power 2, right? So so 2 and 2 get cancelled, so the square root get cancelled, all we have left is 5, right? right? Okay, and so let me actually write this part a little bit below. Okay, let me actually write it over here because I don't have enough space left. And for the top part, what we have is 6. For the the numerator, what we have is the square root of 16 x to the power 3, right? So as you can see, we are able to actually simplify a little bit more, right? We are actually able to simplify a little bit more than that. So 16 is actually the 60 is actually equal to 4 multiplied by 15, right? And x to the power 3, it can be written as x squared multiplied by x, right? Okay, so as further, 4 is actually equal to 2 to the power 2, and then we having x squared, and then we have multiply 15x, right? So we have 15x, and then after the simplification, as you can see, we having a square root, and then we having 2 to the power 2, x to the power 2. So those things, those two variables can actually get rid of the square root, right? Okay, so basically all you have, as I think I repeat so many times, you want to solving. So if you want to solving a square root, you basically want to make something to a square to the power of 2. So that's basically your goal, and that's basically why I do it over here, right? You can see I having a 2 to the power. I basically make 4 to the power. I basically make 4 equal to the 2 power of the 2, right? And I basically making this x to the power 3 equal to x squared multiplied by x.